Hi, in this video we are going to talk about the square root and simplification of radical A. In this video we are going to expand what you know about exponents, which is the small number here, and we are going to know what is the inverse operation of exponents, which we may call them roots. But first, what is an inverse operation? So the inverse operation of a plus is minus. It's what like kind of it undo what the plus do. So the minus undo what the plus do, and the plus also. So if we have plus 2 minus 2, they sort of cancel each other. The inverse operation of multiplication is division. So also division undo what does multiplication, and the inverse is right. So if we have times 2 and divided by 2, they sort of undo each other, they cancel each other. And now we are going to study more about the inverse operation of exponent, which is roots. So as we know, 3 squared is 3 times 3, which is equals to 9. And negative 3 squared is minus 3 times minus 3, which is equals to 9. Then we say that the square roots of 9 are 3 and minus 3. Okay, so the 3 and minus 3, they are the square roots of 9. We call them squared because 9 is obtained when we multiply 3 two times. It's a 3 squared. That's where the square comes from. And roots, because it's relative to trees, and it's the origin of trees. And 9, the square roots, the origin of 9, the square roots of 9 are 3 and minus 3. Now, so the symbol of square roots is radical, but here's a tricky thing. Whenever we have radical, it means that we only need the positive square root, except for the radical 0, which is 0. But other than that, for all numbers, radical number, it means we only need the positive square root. So radical 9, we only write 3, and we do not write negative 3. So the square roots of 9 are 3 and minus 3, and radical 9, it means we only need to find the positive square root, which is 3. So let's practice a little bit. Find the square roots of 36. So they want from us the square roots, the origin. 36 is what multiplied by what? So the square roots of 36, they are 6 and minus 6. Because 6 times 6 is 36, and negative 6 times negative 6 is 36. Find the square roots of 81. The square roots of 81 are 9 and negative 9, because 9 times 9 is 81, and negative 9 times negative 9 is 81. However, when they ask us to write the radical 16, it means we need the square roots, but only the positive square roots. So radical 16, it is 4. We do not write plus or minus 4. Radical 16 is 4, the positive one. Radical 25 is 5, because 5 times 5 is 25, and here 4 times 4 is 16. Perfect squares are the easiest to calculate because we already know the multiplication tables. Radical 1 is equal to 1. Radical 4 is equal to 2 because 4 is 2 square. Thus, radical 4 is equal to 2. Radical 9 is equals to 3 because 9 is 3 times 3. 9 is 3 square. Radical 16 is 4 because 16 is 4 times 4. 16 is 4 square. Radical 25 also is equals to 5. Radical 36 equals to 6, and so on. Some numbers do not have a perfect square. So how do I calculate, for example, radical 8? By prime factorization. So I do the prime factorization for 8. I divide it by the smallest prime number until I have finished the prime factorization, and then I group each two prime numbers together if they are the same, of course. So I group 2 squared, and this one I have no another 2 to group it with it, so I keep it as it is. So 2 squared times 2. So radical 8 is radical 2 squared times 2. Then the square is cancelled with the radical, and this 2 is set free outside of the radical, and this is 2 will be stuck in the radical. So the answer is 2 radical 2.
Another example, how do we calculate radical 45? So by prime factorization, I do the prime factorization of 45, I divide it by the prime numbers, and then I group each two prime numbers together. So 45 is 3 squared times 5. 5 I have no prime number to group it with, so I keep it as it is. And then the square of a 3 is cancelled with the radical, and this small 3 is set free outside the radical, and this 5 will be inside the radical, so it's a 3 radical 5. How can I calculate 7 radical 45? Notice what happened here. So we have a number outside the radical and a number inside the radical. But guess what? It's the same. So this number outside the radical, I ignore it, and then I do a prime factorization of 45. So here it is. And then I write that this number outside, I keep it outside and I ignore it completely. So I just write the prime factorization of 45 under the radical, and I work normally as I worked up above. But when I move this 3 outside of the radical, and then we have a number, what should I do? I multiply these two numbers together. So the number that comes out of the radical will be multiplied by the number that already exists outside, and then 7 times 3, it's a 21 radical 5. And now let's try to solve the prime factorization of 450. Well, don't be afraid of big numbers because it's the same idea. So I performed the prime factorization of 450, and I divide by the prime numbers from the smallest one until I finish it, and then I write it as a product of prime factors. Notice how I write it. I group each two prime numbers which are the same together. So 2 squared times 3 squared, these two together, and this 3 have no other 3 to group it with, so I keep it as it is, 3, and 5 also do not have another 5 to group it with, so I keep it 5. Then radical 45 is equals to radical 2 squared times 3 squared times 3 times 5. Now, the square for the 2 will cancel the radical for the 2, and this 2 will be set outside free, and the square for the 3 will set this 3 free outside of the radical, but this 3 and this 5 will be inside the radical. So the 2 and the 3 will be outside, and we will keep the multiplication times between them, and the 3 and the 5 inside the radical will keep the multiplication sign also between them. And then we multiply, so it is 6 radical 15.
Sometimes it's easier not to find the prime factorization for certain numbers, especially numbers that have zero in them. So the numbers that have zeros in them, for example, radical 300, it's easier for us to write radical 300 is 3 times 100. And 100, we know that 100 is 10 squared, then 3 times 10 squared, 10 squared is released free outside of the radical, it's 10 radical 3. So whenever we have many zeros, it's easier to write it as this than to write the prime factorization, but you can use both ways.
Now sometimes we are asked to find the answer of radical 3 power 4. Well, guess what? If it is an even power, it is very easy. We just need to ask ourselves, 4 it's 2 times what? So 4 it's 2 times 2, and this square we will use it to cancel the radical outside, and then this number inside will be the answer. So one square we use it to cancel the radical, and the other will be in the answer. Another example, radical 3 power 6. So also this 6 is an even number, thus we'll ask ourselves 6 is 2 times what? And always we write the 2 outside, and the 2 we will use it to cancel the radical, and this number inside the parentheses will be our answer. Another example, 3 power 14. So as long as it's even, it's 2 times 7. and 2 will cancel the radical, and the number inside the parentheses will be our answer. What if it is even but it's negative? For example, radical 3 power minus 14. No problem. Also, we will ask ourselves 14, it's 2 times 7. Okay, but I'll put the negative inside. So the square will cancel with the radical, and then I will be with 3 power minus 7. And remember, in order to get rid of this minus, I will just move it downwards. So it is 1 over 3 power 7. Now let's see what happens when we have 3 power odd number. So if this number here is odd, look what we are going to do. We are going to like split the power. So 3 power 3 is a 3 power 2 times 3 power 1. Okay, so we reduce it to an even power and an odd power. So 3 power 2 will be set free outside of the radical, whereas a 3 will be inside. So the answer is 3 radical 3. So another example, 3 power 7. We will split the radical into 3 power 6 times 3 power 1. Now 3 power 6, it's an even number, and we will solve it as we previously were solving the even numbers. So it is a 3 power 2, because 6 is a 3 times 2, and the 2 will cancel the radical. This 3 power 3 will be set free outside, the number inside the parentheses, and this 3 have no power 2, then it will be inside the radical. So 3 power 3 radical 3, and we can solve, of course, 3 radical 3, it's a 27 radical 3. Another example, what if it is even and if it is odd and negative? So if it is odd and negative, we will split the power, but we'll have a minus. But don't worry, it's the same. So 3 power minus 4 times 3 power minus 1, because whenever we have the same base, we can add the powers, and minus 4 and minus 1 will be minus 5. Okay, so we split them together, and then this 3 power minus 4, we have solved something like this before. So it is a 3 power. The 4 is 2 times 2, and we put the minus inside the parentheses. So 3 power minus 2, all power 2. And this power 2 outside, it will cancel the radical, and the number inside the parentheses will be set free outside the radical, and this one will be inside the radical, it will stuck inside. So it is 3 power minus 2 radical 3 power minus 1. In order to get rid of these negative powers, we'll move them below. So it will be 1 over 3 square radical 1 over 3, and it will be 1 over 9 radical 1 over 3.